So what I'm going to cover today is basically an overview of how to create geometry to make 3D things, and kind of just like different approaches that exist out there, the tools that exist, and then one approach that I think will be most useful probably for the next few weeks or months for projects. Because there's thousands of tools out there, and even when you just focus on creating geometry like shapes, there's a lot of out there. But for what we're going to be doing in the next few weeks, which are kind of product-oriented objects that are not too big and need to be 3D printed or laser cut, there are certain tools that are better than others. So I'm gonna go through like an overview of these different ways of representing geometry by computers. And over the years, new methods have been made. So one of the oldest methods is something called NURBS, or Bezier surfaces. The one that's probably most common today is meshes and subdivision surfaces. Those are used in special effects. And then there's these other types of surfaces, parametric models. That's a way of like representing geometry mathematically and precisely. Point clouds, which are really good for scan data. And something that I've been learning recently, I didn't know about existed, but like in the past few years have become popular, is something called implicit surfaces or field-driven design. And so kind of examples of each of these, and some of these are actually kind of famous first versions of each of these. So the first 3D graphic model of a computer geometry is this, what's called the Utah teapot, and it was modeled in Bezier surfaces, which these days are called NURB surfaces. And NURB surfaces are precise mathematical curves that can be cut and trimmed and stitched together to create compound surfaces, and are really good for like representing product objects, like boats, toothbrushes, like chairs, cars, all kinds of things like that. They're really good at representing those kinds of surfaces. The next type of surface is a mesh, and the most famous first mesh was the Stanford bunny. It's just like a bunch of triangles that close to form the shape. But these days, meshes are used for all kinds of things, for like visualization, film, special effects. Anything that you're going to be 3D printing gets converted into a 3D triangulated mesh called an STL file. And we will be essentially learning how to generate a mesh at the very, very end of what we're doing. Another type of way of representing geometry is called a subdivision surface. And the first application of subdivision surfaces was in the Pixar movie Gary's Game, or Jerry's Game. I'm not quite sure how it's, where this old man is playing chess with himself. Prior to that, mesh surfaces there was a lot of trouble deforming them. So there was no way of like smoothly creating or representing organic shapes in a computer model. And when Pixar invented this mathematical approach to creating a rough cage that can then progressively become smoother and smoother, that's kind of that was a breakthrough in computer graphics and representing organic surfaces. And these days you can do all kinds of things with subdivision surfaces, not just like humans, but you could even model like like a blade for a fan quite quickly and efficiently. Whereas before subdivision surfaces, you would have to like mathematically type in all the points and define the surface. So another tool that you can use with Fusion 360 if you've downloaded, it's available for you as well. And then a parametric model, that's something where there's certain types of features like cube, extrusion, cuts, circles, and each of those have a mathematical representation inside the computer inside the geometry model, and then you can create when the geometry model runs and follows those instructions, a piece of geometry is generated. This is really, really useful. Basically today we'll be learning how to create a parametric model. And it's very useful for industrial design, mechanical engineering, anything that is going to be manufactured, and if you find need to make changes, you can easily make changes because all of the instructions are stored in the parametric file. And more recently, point clouds and implicit surfaces. I think these are also very interesting areas, but might not be totally relevant for our purposes. Like point clouds are used for generating scan data, which can then be triangulated and create surfaces. And implicit surfaces are these like mathematical functions that, has anyone seen that like pencil holder downstairs in the, yeah, it's like, it got all these holes. Actually, oh no, it's right there. Yeah, this one. It's very, very likely, I'm not 100% sure how that surface was modeled, but it's very likely that it was used using a combination of defining an implicit surface and then combining it with either a parametric model or like a mesh.
Can you give an example of a point cloud?
In this case, what we're actually looking at right now is a point cloud that, in the example here, is a point cloud that's being generated by a self-driving car. So like a self-driving car has something called, a type of sensor called a LiDAR sensor. And the way it works is it shoots out a ray of light, and then it counts how long that ray of light is seen by the camera, and using that system it can basically measure the distances of surfaces. In this case, the point cloud is a kind of geometry with no surface data. It's just dots in space, but you can feed that data to a machine learning program, and like in this case, you can see that it's like detecting cars and like creating these green cages around that. So if you want to, you can use a sensor that reads point clouds as data, and then like label it like, oh, that's a human, that's a car, and then create interactions around it, for example.
When you say create a geometry, what do you mean exactly? Like, is it like just a collection of points? Like, what do you mean?
So when I say create geometry, it's like, how do you get from like basically nothing to representing some shape, or and in case like, yeah, so when I say geometry, I just mean a shape.
Okay.
So every object that we have, like whether it's like this mouse or this water bottle, has a shape, and when I use the word geometry, I just mean like a more precise way of defining what that shape is. So when we're talking about geometry for fabrication, or like any shape that we want to produce, we need to consider how it's going to be made. And specifically when it comes to 3D printing, it can't have like holes or open edges. Okay, I'm realizing that I probably need visual examples of this. Okay, let's see. There are things that a computer can represent that can't be made in real life, basically. And so, for example, if you have like a piece of paper, and then you have another surface, there's no way of like intersecting these without cutting through one or the other. But in computer graphics and computer geometry, you're allowed to do anything. So there are certain, so if you do something that is allowed in the computer world but is not allowed in the real world, you might run into some problems. So in fact, I'm gonna use Blender just to show some examples, even though I won't be teaching Blender. But like, for example, what do I mean by like an open face? Like, this is like a box that's open, and it doesn't have any wall thickness. Like, it's not even a piece of paper. Like, a piece of paper, actually, I could grab my calipers and measure it, and it's probably something like 0.1 or 0.2 millimeters thick. But this box, it has absolutely no thickness at all. Like, I can zoom in and zoom in and zoom in, and it's just nothing. It's just a plane in the world. I cannot make this box in real life. It's impossible, right? So that's what I mean by like an object cannot have zero thickness. If I want to actually manufacture or 3D print this, I would have to add some thickness. So for example, I won't be teaching Blender, but I can add, this can be made in real life. Like this geometry represents something that is analogous to something in the real world. So things like cannot have holes or open edges. Again, that's kind of similar to what we were talking about. Like, if I remove, so if I close this box, it's kind of a cube or a dice, right? But if I open that up again, these yellow edges are open edges. Like those edges, it's just like an edge of something that has no thickness. Those kinds of geometry will create problems. And also depending on what you want to build, consider that like things might need support, or and building something that's hollow might be challenging depending on how you make it. So for example, I think Jose mentioned a couple of these before, but like let's say I were to, if I wanted to build a box that had an opening underneath, and the way I was building it was like using a tool to remove material, like the tool cannot go underneath and remove the material. So like sometimes you have to consider that like a hole can only be at the top because you can only drill and remove material from the top. I put this list here without much context, but I think we can revisit this list a little bit later on once we've actually built something and we can kind of see what's happening. And so yeah, I mentioned briefly like ways of representing geometry, but for each one of these ways of representing geometry, there's a way of like creating or generating it. So for example, 3D scanning, and now 3D scanning is actually really, really easy. There are tools like photogrammetric tools that allow you to stitch multiple images together, and they can produce meshes or point clouds or different types of data, which you can import and you can review and edit and use that as like a reference point. So for example, let's say you were building a prototype for like some kind of handheld tool, and you made something with clay or like or modeling clay that you really were like, oh, this is the perfect handle. Like I tried it out with 10 different people, and each person, they'll hold it and is like, this is nice, don't change anything. What you can do is you can do a 3D scan of that piece of clay and bring it in to a computer program and then use that as a reference, whether it's a mesh or a point cloud. Another way of creating a model, creating geometry, is by direct modeling or precision modeling. And so so that's like if I were to like, you know, take a point and like move it, you know, like I can take an edge and like add another edge. Like that's direct modeling. It's like I'm just going in and like adjusting things by hand. There's no real precision to it, but it's like, but it's used in special effects all the time. Like if you want to like add or remove material to a character, or like you want to maybe like there's like a branch of a tree that's like not right, and you want to like maybe adjust it this way. You can use direct modeling as a way of getting your results. And then, yeah, the one that we'll be reviewing today is called parametric modeling. I think it's the most appropriate for what we're going to be doing the next few weeks. And I hope it's useful, that you can use it, maybe not tomorrow, but like maybe Friday or something. And these ones will produce either like a parametric model or a NURBS model, which you can then generate a mesh out of. Think of it like there is like a hierarchy in representation of geometry. So it's like, have you ever worked with like Illustrator or Figma, and you can create like a nice curve, and you have all the handles and everything. Let's say parametric model would be like, I want to create a moon shape, and I have two circles, and then I subtract one from the other. But like I still have the memory of the subtraction, and I can, if I want to make the moon bigger or smaller, I can move it around. That's kind of like what a parametric model is. It has like a memory. A NURBS is going to be more like, now I expand the shape, and now I just have that shape. I can't like make it like full moon or no moon, but I can still edit the curves a little bit.
Like when you flatten the layer?
Yeah, kind of like when you flatten, or like in Illustrator it's like expand shape, but I don't know, maybe in Figma it has a different name. And then a mesh is like rasterizing it. It's like export to PNG. Now you have like a bunch of pixels, and it's like a real pain to like now edit the overall shape. It's possible, but it's better to like edit the thing that generated the PNG than to edit each individual pixel. And we won't go into field-based design, but it's pretty interesting. And I'll just mention a couple of tools for these ones. Like I've used Polycam and Reality Scan for 3D scanning. Works pretty well. You can use MeshLab to edit 3D scans. So like sometimes 3D scans will have like a hole or it's like some missing data. So you can use something like MeshLab to like patch that data. Or if you have another 3D scan, to use that one to like fix it.
Can I ask a question?
Yeah, of course.
Maybe I missed this, but what would you use to make a 3D were mentioning like a mug with a perfect handle. How would you make a 3D scan of that?
Like, you're saying the object already exists?
Yeah.
How do I scan?
Yeah.
Yeah, you can use these tools like Polycam, Reality Scan. Like,
Oh, okay, so they're like kind of like
Yeah.
camera?
yeah, it's like you can download from the App Store, and you can just take a video of an object. In this case, like they're using like I don't know if this is not a very good example, but
So if
someone's
you took a video of me, you could make like a 3D mesh of me?
kind of, yeah. Not like what I mean is a video is like a video of you like walking around a rigid object. Like if the object is moving, it's gonna cause this software to be very confused. But yeah. No, I don't think so. Some of them do, but a lot of them just use photogrammetry, so it just uses some like very advanced math. But yeah, there are more precise ways that we don't have access to here, like for automotive modeling, where a design studio will create a clay model, and then they'll actually use like a scanner to scan the surface and bring that data into a CAD model. But those are like very expensive and complex systems that we don't have access to here. Yeah.
I actually have a question about something that you. So I was just going through some like pictures and trying to understand. So the mesh and the subdivision surface that like. So the way that it looks like you start to add more surfaces when you're doing like subdivision, right? When you I don't know how to explain.
Yeah, I'll use the Blender as an example. As so subdivision surfaces. You're asking specifically about subdivision surfaces?
No, I just really wanted to understand the difference between three and how do you use them in a way. Like, what is the purpose of, like, if I look at one figure, I can look at it in these three ways. Like, if it's just a cube, right? I can make it. I can add more subdivisions to it in a way. Like, I just wanted to understand.
So, yeah, maybe okay. Yeah, just bear with me. Like this is the first time I'm like trying to explain something like this. You can if it depending on the type of object, you can bring it into your computer and represent that shape in various ways. And some shapes are better with using one approach than another. So shapes that are like very smooth and free flowing, like this rubber ducky has like a lot of smooth curvature. Something like this would be easier to represent with either subdivision surfaces or nerves. But whereas something like this, which is this like very hard edges, mechanical, lots of different parts that come together, using like a parametric model would be a better approach. And some things are kind of in between. Like this is it has a little bit of curvature, but it also has some precise features. I mean, ultimately it's kind of up to you to decide what would be appropriate, but depending on what you want to do with it as well, also might define what approach you would use to build the model. In this case, I would probably suggest using again like a parametric modeling approach, like again Fusion 360. But let's say you don't want to actually build this in real life. You just want to do you have the marketing team says, oh, we need like a picture of it. Then you don't need to do it. You could just render the image from a mesh or something like that. So the different forms of geometry can be translated to each other and have strengths and weaknesses of each. And I think if you have more questions, I could try to add more information to the slides and then just share it and have more examples, if that helps. So when yeah, there's these two last things before we actually try and build something, which is like when should I use 3D and when should I not use 3D, and so like if you're going to put the time and effort to create a 3D geometry, 3D model, you want to invest that time because you have a reason to do that. And the kinds of reasons I could come up with are like, I need to 3D print this, or I need to cut this, or rapid prototype, like use the laser cutter. Another reason you might want to use a 3D model is like to communicate to fabricators. It's like sometimes like you can't build everything by yourself. You need some other people to help you. So building a model and like sending it to them, or like taking some screenshots and putting some measurements and sending that information to them, and will help you communicate what you want to build. The renders, marketing material, and visualizing design intent is also something that's used a lot, especially by industrial designers, to kind of get buy-in from a product. So in addition to building physical prototypes to say like, oh, this is how the object will work, the designers will create pretty renders with like nice lighting, and they'll put it in like a scene, maybe before any of the resources are available to actually build a model that looks like it in real life. So you can generate those things using computers. And then two other things that are useful are like doing analysis, like simulation. It's like you want to, can this handle like the load of like an elephant standing on it? Like you can give a 3D model to an engineer, and they can actually do a simulation on it and then test it to see if it can do that. Or like a car design, like a designer can create a 3D shape of a car and say, well, like how efficient is this at driving? And then they can give that to an engineer, and they can put it in a virtual wind simulator or like a wind tunnel, and basically test using simulation tools. And finally, documenting dimensions and how you build something, so that later on you can communicate to other people. And just as important is like when to not use 3D, because building 3D models can take time. So like when you're trying to figure out, like these things should be obvious, but it's still important to remember, like when you can use a prototype using like hands-on traditional tools to build something. When you can find something off the shelf that you can use to represent what you're trying to build. Like when you can use an object that you found. Like there are a lot of times where you don't need to build and 3D print and like make a render. You can just do something with your hands or with like the tools at your disposal. I think with that, let's just like build something together and like learn this. Oh yeah. So, okay, there's a couple of things. Yeah, before you start building something, it's really good to know what you want to build, because a 3D program is not a great place to play around and experiment. Like it's way easier to experiment in the real world with like paper and clay and cardboard and like, is this the right size? Is this like, does my hand fit in it? Like, is this like, is the handle the right size? Like those kinds of things, is the button in the right place? Those things, a real physical model, before you invest time into building 3D is really, really important, because building 3D takes a lot of time. And I know like from personal experience, you can spend like hours, even days getting the right thing built. So come in with a good design intent, with a sketch that describes what you want to build, have your dimensions, have like a plan view, a side view, and I'll go into these later. So basically, I thought this might be a fun thing to build. It's a camera. It's not too complicated, but it's not too simple either. And it has most of the features I think will be useful over the next few weeks. And I've also created like a little sketch of what that kind of the dimensions that would be. So I'm going to use this as a reference when I build this camera. So does everyone have Fusion?
Can I ask something?
Yeah, of course.
I was gonna ask so these objects we building is could be living in abstract world,
Yeah.
and while you are building, maybe you came to a complex point, but you still don't know if this is feasible or not, yeah? Or is it some like guidance, or just you can produce this, or just it's like some beautiful object that I did?
So that's a really great question. Well, it depends on what your purpose is. But let's say for our purposes, let's say our job as a designer, as a design team, was to come up with a new camera. And maybe the overall form, shape is kind of decided, by tradition and history, and we know that that's something that works. But there's a lot of things that we don't know, like where do we put buttons, and where do we put switches, and like where do we put the display. We can create like low fidelity models to test that out, but then there's a certain point where low fidelity model isn't good enough. It's like there's a point where we start defining more and more details. Like now we actually need to put a real button that actually works, and like a real switch that works, and a real display. And using a 3D modeling tool, we can plan that out, and we can prepare a file that we can 3D print, and then have all those parts and glue them together and put in our buttons, and then it becomes like a much more real object. So in this case, it's a kind of a mix of industrial design and interaction design, where we're combining like interfaces and form to create one step closer to our final design intent. Yeah. Does that answer the question?
Yeah, but I was also wondering, like, I designed something, what if, I'm not sure, maybe ignorant question, but what if that doesn't come out in the real world, and it's not printable? It isn't something, but the machine cannot print because it is physically impossible.
Well, those are why I had a list of these things.
Those are my consideration, or did the program consider those things?
These are considerations both for the program and for the method of fabrication. So these kinds of these ones are program considerations, like self-intersecting surfaces, holes, zero thickness. Like if the program reads this, it's like, I don't know how to make this in the real world. Or if the program is really smart, it can make a guess, and maybe it's what you want, maybe it's not what you want. These ones down here are more like how does the machine actually build it? Like the 3D printer can't just like print on empty space. It has to like build up material before it does that. In which case, they're like the Prusa software, the Prusa slicer, it can it can be like, oh yeah, there's negative space here. I suggest you add support material. But we as designers and like people who, you know, are thinking as we're building this, we can kind of plan ahead of time and be like, oh, I can break this model up. I'll show you what I mean. So yeah, let's build this together. Right? Do you want to build this camera together? Okay. And it's a very like loose sketch, and we can kind of figure it out as we go along. You have a question? Okay.
Sure.
Yeah.
Do you usually need that kind of dimension before you jump in? You do
It helps. If you don't know exactly, it's okay. But I think for the purposes of this situation, we don't want to spend time like guessing and figuring things out. So it's best to have a pretty good idea. So this is the interface of Fusion 360 or Autodesk Fusion. I'm kind of gonna just walk you through the elements of the interface. At the top of the screen are the features and tools that we can use. On the left is this browser, and as we create objects and components and different geometry, like different parts, they'll show up here on the left side. On the bottom, there's this like, it looks like this music player, right? This is actually going to be your history. Like as you build your model, it basically records all of your actions. So you can go back at any time and change an action, and it will rebuild everything in the future, respecting that action. It's a very, very, very useful thing when you're iterating on designs. So it's like you make one version and it's like, oh, it's 20 millimeters wide. And then you test it out and it actually needs to be 30 millimeters wide. Instead of building a whole new model, you can just go back and then change that measurement from 20 to 30. The way that I have my settings set up is that I use a 3-button mouse. So if you don't have a 3-button mouse, it'll be a little bit more challenging to navigate the scene. But you have this tool up here, which is called the view cube. So the view cube, if you click and drag it, it allows you to pivot around the scene. And if you click the different views like right or top, it will jump to those views. So we're gonna click on top to enter the top view, and we're going to start drawing the base for the camera. And the way that this program works is you build sketches and construction geometry first, which are kind of like curves and lines in space, and then from there you can build like solid volumes from those shapes. So I'm going to, from the top view, I'm going to select the XY plane, and I'm going to click create a sketch. And so that's going to enter a sketching view where I can create a shape. And so I'm going to start with this 2-point rectangle. Well, actually, I'm going to just use the line tool. I'm going to switch over to here. So we want like a kind of, it's almost like an L. So I'm going to, so 125, it's all in millimeters. And then 35, I think, 35.
Wait, sorry, what did you click on to get the line?
So there's this, you can hit the L key or click on the line tool. And there's a lot of different ways of doing this. We can also, you can do line, 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 like that. And some of these aren't dimensioned, so you can kind of still move them around, right? You see that? So in my sketch, I haven't defined everything, so I'm gonna kind of like eyeball it. So that's kind of like that, and kind of like that. And I'm not adding any of the round. There's another feature I'm gonna use afterwards to kind of round it all out.
Felix, I have a question. If we want to be precise with like 125 or 35 millimeters, is there a way to just type it in after you plant like an initial line?
Yeah. So there's, I think it's in, oh yeah, it's in create dimension, or D. And now the dimension tool is activated, and I can select any element or multiple elements, and now I can add a dimension to it. So I selected this top line and this bottom line, and now I can type in 50 millimeters, and now it's dimensioned. Does that answer your question?
Yes.
Does the dimension just mean that it displays the length?
So the dimension creates a driving dimension. So right now, so let's say I want this to be this length. Okay, let's see. So let's say I want this length right here to be 25 millimeters. But I have no idea what the length is. It could be anything. If I put in the dimension tool and I put in this 25, it'll force that length to be 25.
So the blue line I see is like, can you undo this? Yeah, the blue line, that's sort of just calculating its height based on the other lines around it.
Yes, exactly. And the reason all these lines are black and this line is blue is because the black lines mean that they're well defined. That means that there's no other place in the sketch that they can be. But this blue line, it could be anywhere. In fact, you can see because I can click and drag it, and it could be anywhere. But the moment, the moment I dimension it, it becomes black. That means that it's well defined. So does everyone have this basic outline? Okay. So now I'm gonna finish the sketch. And now I'm kind of in the 3D world again. And I can create a volume out of this using the extrude feature. So extrude, if I don't have the sketch selected, then I'll have to select the sketch. And I have a little panel on the right side, which are all the parameters of the extrude tool. So the first one is the type of extrude that it's doing. In this case, I'm extruding the entire area. The next one, this is a really, really useful tool. Always just read through everything to make sure you are doing the operation or creating the feature correctly. In this case, I have one profile selected, so which is this blue profile. The starting position is where does the extrude start, the direction, and then until where does the extrude go. And so in this case, I'm starting where the sketch is, the profile plane. I'm going in the direction, one side. There you have a couple of options, two sides or symmetric. And then the extent type, you have a couple of options, but in this case, we're gonna stick with distance. And the distance, I'm just gonna refer to Gahan's really nice prototype. And I will go with 55 millimeters. So And you can also use the arrow, this little arrow, to kind of dynamically move it to that position, or you can enter it in here. And then the last step is also keep an eye out on this operation, new body. This means that we're creating a new geometric body with this extrude feature. And so now we have our first geometry.
Okay, done.
Yeah.
This is
So the next thing I'm gonna go back to my sketch over here, and I kind of want to get this like the round geometry in here. So for that, I'm going to use fillets. The fillet is like a very useful feature that adds kind of a round to any geometry. So in this case, I'm gonna add round to here, and I can use the I can't. That's not. So I'll select the edges that I want to round, and then I can type in the diameter. No, sorry, the radius of that round. So let's just put in something to see what happens. So now I put in 10 millimeters, and you can see that there's a round fillet that's modifying that edge, and the radius of that curve is 10 millimeters. In my sketch, it's like completely round. So I'm gonna do, this is a nice thing about Fusion, is I can do math in here. So I'm gonna do 35 divided by 2 millimeters. Oh, usually, oh no, can you, does it work?
It worked for me.
It didn't?
It did.
I don't know why it's not working for me, but usually it works. You can 35 millimeters divided by 2. Okay, there we go. I guess it wants the millimeters before. Okay, so now I have like a round for that side, and I can go in and continue doing that for these other areas. So 35 millimeters divided by 2, like that. And then these ones might be a little bit smaller. I don't know. 5.
So, are you selecting the surface or just the edges? Because mine
Just the edges.
Mm.
Yeah. So you can fillet a surface. If I click a So if I click this entire surface, it will try to fillet the edge that is the boundary of that surface. You see? But sometimes that can be, sometimes there's no solution for that. And if I keep making it bigger, see, like if I make it like, let's say I do 10, okay, yeah, it keeps getting bigger, but there's a point where, there's a point where the surface geometry will create a self-intersecting boundary, and at that point, which is about it's just over 12.5. So if I do 13, something weird is going to happen. Okay, in this case, it just deleted all its geometry, but I don't want that, right? So yeah, I'll finish the body by adding rounds to these two. And these ones I'll do 12.5 for the handle. Okay. And now we kind of have like we're kind of getting the beginning of our camera body. So the next thing I'm gonna do is I'm gonna show you how to create a kind of construction geometry. So in this case, I'm gonna do something called an offset plane. So offset plane, see that? Construct offset plane. And I'm going to select the XY plane, the base of my model, right? And I'm going to create a new plane that's offset at a certain height. And that height is going to be the full height of the camera body. So in this case, it's 70 millimeters. 70. Okay. So now I can create a new sketch. So now I can use this plane to do a new sketch. You can sketch on any plane that exists, right? So the XY, like the top plane, the front plane, the side plane, those already exist. But sometimes if you want to make a sketch in an area that doesn't exist, you need to create construction geometry for that. So in this case, I want to create the profile for the top of the camera, and because I don't have any geometry there, I need to create a new sketch. So I'll click on that construction plane, and then I enter I click on the sketch tool, and now I'm going to create a new sketch. I'm going to add some more, go over some extra features of the line tool. But just first of all, how's everyone doing? I realize there's a couple of things I'm forgetting to tell you all. Again, so if you take a look at what we have right now, if you look at the bottom of the screen, there is this kind of, it's kind of like a list of these features, right? It says sketch 1, extrude, fillet. This is the history of my construction. And at any point, I can grab this little timeline and I can kind of rewind. And so now I'm back at the beginning, right? I can see each step of how I built this. Let's see, right? And any of these features I can change. So if I go, let's say I don't want a full fillet right here, I can select this fillet, I can right click on it, I can edit the feature, and I can type in a new measurement. So let's say I don't want it to be this one, I can put in like 15 millimeters. And now I edited that fillet to be 15 millimeters. Same thing with the sketch. If I click on this and I want to change that profile, like let's say I want this handle is not sticking out far enough, actually, like it needs to be longer. If I right click on that sketch, if I edit it, I can go and click on that, double click on this, it needs to be 55. Now it's a little bit longer. I click finish sketch, and now that handle feature has come out longer. If I enter a feature, as you can see, it's going to jump to where that feature is, and it's not going to show any of the features that come afterwards, so they're grayed out. And then only once I click OK, then it rebuilds everything afterwards. Same thing with the sketch. If I'm in the sketch view, I can't see anything that was built afterwards until I finish the sketch view, and then I go back into the view, and then... Okay, let's keep going. So I've started a new sketch on this plane right here. I'm gonna turn off my grid.
Felix, just a small question.
Yeah.
When, like, for example, I was editing the dimensions, how do I come out of it?
So if
Yeah, like I was editing it.
you're editing the dimensions, like you're editing this sketch, you'll have to hit finish sketch. So I'm gonna edit this sketch that's on this plane here and return to my design intent. So what I want to do is create this new profile that's a little bit set in. Do you see that? Like, so we've got the outside shape and then we have this like kind of inside shape. So I'm gonna create using the line tool, I'm gonna loosely sketch out what that looks like, and I'm gonna turn off snap to grid as well. So if I click once and then I move the cursor, now if I click again and click and drag, it creates an arc. You see that?
Yeah.
And then if I let go, it creates a line again. And if I click once, it creates another line. And if I click and drag, it creates an arc. And if I click once, it finishes the line. Oh, actually, I want an arc here. Oopsie. I think I can click and drag. All right. I basically have what I want, but I need to connect them. So click and drag. And then I want, see, as you can see, this line and this line are not tangent. So I'm gonna click this line and click this line. And over here I have this button called constraints, tangent. And if I click on it, it makes them tangent. So now I kind of have this profile and I can kind of play with it. So what I want is, going back to the design intent, is that this top profile comes out a little bit like that. And this is like this. So this is basically what my design intent is. And now that I'm kind of happy with it, I'm gonna dimension it. So I'm gonna enter the dimension tool and select these lines. So that's 5 millimeters. And select these two lines. Oopsie, no, that's not that one. Sorry.
Felix, before going,
Yeah.
I lost something. Which one did you start with in the first place? Like with the points? Or this
Are you asking about
line or
how I created the shape?
Yeah, because I think I missed that part.
Okay, this is a really nice feature of this tool. It's just the line tool, but the line tool is actually many tools in one. As you can see, it's not just a line, it's got like a line and an arc as well in the icon. And if you kind of hover over it, it shows you that you can create line segments and arcs if you click and drag. So let's just move over to a new blank space. Let's say I want like, and you can just kind of play around with this to see how it feels. But like, let's say I want to make like a shape. What kind of shape would I want? Like A for Ali. So I can just kind of like, I can kind of click and drag. You see that? I can kind of quickly rough out a shape. Okay, it's not perfect, but you know, you kind of get the idea. And then you can add in more details afterwards, which is what I did. So for example, in this case, like I want, you know, this to be the same height as this. So you can select those two elements and you can do horizontal. So now they're always the same height. So the constraints and dimension are a way of like defining your sketch. In this case, I don't like this little feature right here, how it's like not tangent, so I can make it tangent. And now I have like a nice A, which I can then extrude. A for Ali. If you're having trouble with the arc tool, we can just do the same shape again. Duck, 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 you know. Like that. And then you can add rounds as well into the sketch somewhere. Arcs. Oh yeah, modify. Fillet. So do you see the modify tool right here? So I click on the fillet, and now I can just add the rounds to it, like that. That might be a little bit easier than what I was doing before. There's no wrong way to do it. They're all valid. I'm gonna delete these for now because I don't need them. And okay, so now I'm not gonna dimension everything, although it's good practice to dimension it. And I will finish the sketch. And for some reason the sketch was invisible. So if a feature is not visible for some reason, you can look for it in this sidebar and kind of turn it on. So like earlier I noticed that this plane was invisible, but I kind of want to reuse it, so I can turn it on and off. It doesn't delete it, or it just makes it invisible. And when you have a complicated model, it's nice to be able to hide things you're not using anymore. Cool? Okay, so I'm gonna show you another feature which is super, super powerful for creating geometry, and that's the loft tool. And that allows you to basically create a connection between two different shapes. This is actually how boats were made way back when. You would like draw each cross section over and over and over again, and then you would use this. You would build a loft between them. But now it's not boat building; it's just 3D software. So in this case, I'm going to create a feature using this loft input and this loft input. And as you can see, the software tries to create a connection between the two. There's a couple of important things, which is like, where does the starting point of one, like this, because this is basically a boundary, one boundary and another boundary. So like, where is the beginning of each one? And so fortunately the program was smart and it figured it out for me, but sometimes it's not that smart. And you have like different ways of connecting them in here. And in this case, as you can see, it's got this curvature. I actually want a very simple loft. So I just want, oh, interesting. How do I? Oh, I see. This surface is twisting. I might need to create an additional rail. Oh, this is a feature I haven't used before. Oh no. Let's see. Sorry, I'm noticing there's a problem with what I'm trying to do. I think the solution for now is just, yeah, let's do this. Yeah, there we go. That's what I want. Okay. Um, Loft is really, really powerful, but it can be a little bit annoying. And in this case, like, what helps is, so let's say I want to match this surface to this surface, or that boundary to boundary. Like, let's just count, okay, 1 edge, 2 edge, 3 edge, 4 edge, 5 edge, 6, 7 edges. If the number of edges on this top boundary and this bottom boundary are equal to each other, then the math is really easy. I'll just like blend each one. But what I had earlier was I actually had an extra surface here, which meant that the bottom had 9 edges and the top had 7 edges, and it was beginning to twist as it went around. So to fix it, I just made them the same. I don't know if that's making sense to you, but
I think I'm also having kind of, because the other panel is kind of rectangular for me, so it's giving an error. Doesn't do it.
are people like a little bit lost with this feature? Okay. Don't worry. We can disregard this one for now. We can still build a camera without this shape. We can kind of simplify it for now. So the next thing that I'm gonna do is add the objectif. I don't know what you call it, the lens. And so for that, I'm going to here we go. So I'm going to select this plane and create a sketch on it. So you can just select any flat surface and create sketches on it. So in this one, I'm going to create a sketch here and create a circle that represents my lens. All right. And then I'm going to create, I want to see, can I construct axis through, no, axis. I'm going to extrude this feature a little bit here, and in the other direction, 2 sides symmetric, and make it a join feature, and make it 10 mils. So yeah, don't worry about this loft feature. For now, it's let's just add this circular section as well.
When you make the circle on this plane,
Yeah.
how do you center it, or do you continue?
I just eyeballed it, but if you do want to center it, there are ways of doing it. So depends on what you're centering to.
Yeah.
You can use any geometry that exists for reference. So in this case, I have like this line. What I can do is I can create a line that's connected to here and then goes up vertically. And I can make this a construction line.
Okay.
By it here, normal, make it a construction. And then I can select this line and this point and make it midpoint. And now I can align this to this. So now they're centered.
Thank you.
That's one way of doing it.
Construction, what is construction line?
A construction line is a line that when I exit the sketch, it won't be used to create geometry.
Okay.
So in this case, so if you can see, like if I edit this sketch, I have a circle. But if I make this not a construction line and it's like a real geometric line, then the feature that I can choose, I have to like select more. Like now I can create an extrusion based off of that line, right? But if I make this a construction line, it cannot use that to create geometry. So I just get the circle. Constructions, lines, it's just a way of like simplifying your sketch. How's it going, friends?
I have another question.
Yeah.
So when you made the new construction plane and then made like a line
Yeah.
shape, line
This
geometry,
shape here.
yeah, I tried to just copy paste it from sketch 1 and then did it,
Yeah.
but then I was able to loft it and join it, but I wanted to make it similar, like you have a longer handle, right? This way.
Yeah.
It was straight up for me. So when I edited the sketch, it didn't really change the shape.
Okay. Well, so there's two things that, one is like so let's say we do what Vedant was thinking is like, I can take a sketch, yeah, I can copy it, and I think I can paste it, right? No? Oh no, no, I can't do that.
Like I was able to paste it in that sketching.
Oh, you just copied
Yeah,
everything?
yeah.
I see. Plain sketch. Oh, I see. Okay. So you're saying that you had some issues with.
Yeah. So I pasted it here,
Yeah.
extruded it, and then when I edit the sketch after extruding it, it doesn't update the 3D shape. It only updated the sketch.
Okay. Well, we can take a look at it together. Okay. And so, okay. So now we kind of have the body of our camera, right? This is the body of our camera, more or less. We can add some more features afterwards, but I think for now this is not bad. Let's build the lens, and we're going to build the lens as a separate component. So the first thing I'm going to do is I'm going to create a construction line, axis through cylinder, and I'm going to select this, and this will kind of create an axis geometry that I can use to build our lens. And I will also create a construction plane. I wonder if I can. Sorry, construction plane. Point at center, okay. I also need to create a point. So now I have a point and a plane, and I will create a plane that's offset, sorry. Plane. Plane tangent to faces point offset. Oh, here we go. I think that's. I'm sorry. Oh, yeah. that was a little bit more complicated than I expected. But so I want to teach you this other tool called Revolve, which I think Gayatri used the other day for a project. And basically I'm creating a sketch plane that's at the center of our lens body. And what I'm going to do is enter the sketch view. And now what I can do is I can kind of create the profile of my lens. Okay. And okay, this is not, it's not perfect, but you know, you get the gist. Something like that. And we can use the revolve feature. It'll figure it out automatically if I've set everything correctly. Oopsie, sorry. Edit feature. And then I'm going to do this. In the edit feature, I'll make sure that I select, 360 degrees and then new body, and then click OK. And so now I've got my camera body and my lens as two.
Oh,
I looked at it for one second.